Good morning, pre-calc peeps. I am going to show you how to do the nonlinear systems by elimination. I'm going to do one example, and then I'm going to pull one off of your homework to do with you because you have 6, and 6 seems like a lot. So here we go. You should have, by now, done the nonlinear by substitution, but substitution requires you to get one of the x or y's alone. And in a system like this, that would be really tricky because both the x's and the y's are squared, so you'd have to introduce a square root, and it would get really complicated. Also, you should have done solving by graphing. Well, graphing requires you to put it in your calculator, and that requires it to start with a y equals, which this one won't do either. So we haven't done a bunch of higher level graphing, so we don't maybe recognize what these are right away. They're not necessarily lines or parabolas. But I'll talk to you about that at the end to kind of show you what that would look like if you graphed it. Whenever you have squares, you introduce the option of plus or minus, which means you end up with more answers than you do when you have just plain x's or y's. It kind of doubles your answer options. So we've done elimination before, and the goal is always to have an equal but opposite pairs of something so that they eliminate. So this one is pretty straightforward. It's ready to go. You can see that these two already are going to cancel out because a positive y squared and negative y squared cancel out. Then I combine these to have 2x squared, and I combine these to get 18. Dividing by 2, x squared is 9, and then when you square root, keep in mind you have to introduce that positive or negative option. So I end up with the possibilities that x equals 3 or x equals negative 3. And then I need to go back and find my y's, and I can plug it into either one. I guess it doesn't really make any difference. I'll take the top one. I would take my x, which is 3, square it, and then I'm going to solve for y. So 3 squared is 9. When I subtract that 9, I've got this. And when I square root, again, same thing. I have to keep in mind that I'm introducing that plus or minus possibility. So what that is telling me is I'm going to need to go back here. And when x is 3, y can be either 2 or it can be a negative 2. And so I'm going to zoom this out a little so you can see more of what's happening. Sorry about that. So I actually have 2 points so far just from that one x value. And what's going to happen here, if you think about the math you're doing, when you plug in a negative 3 to that same equation, the exact same math is going to take place because as soon as I square that negative 3, it becomes a positive 9. And so then this becomes the same. So the same thing happens. When I put in a negative 3, I either get a positive or negative 2. So this system actually has 4 places that it would cross. And the reason for that, and you don't need to know this, is if you did know how to graph these off the top of your head, this top one is a circle, and this bottom is something that we call a hyperbola, which is 2 parabolas facing away from one another. So that particular combination or systems of equations would have 4 places that it could cross, and that's where we get our 4 solutions from. Now, you won't always get solutions, or 4 of them. Let's say that we had a circle and a parabola. That might cross here, here, and here, and then I'd have 3 solutions. You could have a circle and a hyperbola where there were no solutions. It just really depends on the values involved. So you have to go through the math to kind of determine that. Okay, so let's go through one more example, and I'm just going to switch paper here so that this is easier for you guys to see. Let's take one off of the homework. And these obviously are chopped out of the middle of something because it starts with 19. 19... Oh, well, excellent. 19 actually was from your homework. Okay, so let's try something else. I don't want to do all your homework for you. I know you'd be sad about that. Let's say I had x squared minus 2y equals 8 and x squared plus y squared equals 16. So this one's different because these y's can't cancel out because one is squared and one is not. So I'll have to work on eliminating the x's instead. So I'm going to do that by multiplying the entire bottom by a negative 1. So if the top stays the same, and then I distribute a -1 to the entire bottom, I'm going to end up with these values. And the beauty of that is that this will cancel or eliminate. This becomes negative. Oh, excuse me, that's not going to become -3y squared because that's not squared. I'm going to have a -y squared from this, and then I still have this -2y. Excuse me, Penny, that's not your food. Get out of there. My dogs are eating each other's food. Go, that's not your food. And then on this side, since these are both numbers, it still equals -8. So here I've got a quadratic, and I don't like having the front part negative, so I'm going to go through and I'm going to change all the signs. So this is going to become this equation. When I bring everybody to one side, since I need quadratics to equal 0, I'm going to subtract that 8 over. And then I'm going to look at it and decide if it's something that I can factor or if it's something I'd have to use quadratic formula for. And in this case, it factors because I can make 8 by taking 4 times 2, which will give me a +2 in the middle if I have a +4 and a -2. Trying to get those to equal 0, so I would have to have a y value of 2 or a y value of -4. So those are my two options. Now be careful because that means I'm going to have those as y values. So when I write my answers, I need to make sure that those are put into the y position. Now to find my x's, I go back to either one of the original equations. It doesn't really make a difference which one. So let's say I chose the top one. I don't know my x's, -2, and then I plug in the y value that I got. So I have x squared minus 4 equals 8. X squared equals 12 because I'm adding that 4 over. So then x is going to equal, and because I'm introducing a square root sign, I'm going to have plus or minus √2. So you can do one of two things. You can either say, hey, that splits into 4 and 3. So the really math way to do it would be this, which means that when I plugged in the 2, I actually have two different options for x, either 2 √3 or -2 √3. That comes out to be about 3.5. So if you had a 3.5 here and a -3.5 instead, that would be fine too. Then I'm going to repeat the same thing for my -4, plugging that in for the y value because it's the y value that I found. I have that x squared plus 8 equals 8. So when I take that 8 away to the other side, I end up with a 0, which obviously a plus or minus 0 isn't a thing. So there I only get one answer. So having 3 solutions seems kind of weird, but this is one of those scenarios that if I did know how to graph them, this bottom one is a circle, and this top one's a parabola that actually has its vertex right on the circle. So like I had drawn in that other sketch, this has 3 possible options. And so you don't need to know this part in terms of the graphing, but it just helps to understand, like, how would I get 4 solutions or 3 solutions, because you're not dealing with lines, and round things can intersect in more ways than straight lines can. So hopefully that helps you out. I did do one of them off of your homework. And if you're looking for an answer key, keep in mind that you can always just plug in the x's and y's that you got to the original problem, and if they work, then you've done them correctly. So hopefully that helps you. If you have any questions, come see me at 1:45 in the meeting room. Thanks, guys. Bye.